Hello, so today we are having the topic of array multiplier and binary multiplication using shift and add method. Let's start. First of all, we need to understand what is basic binary multiplication. I am doing here, you just need to see the steps. Whenever we multiply any digit with 1, we will get the same output. Like 1 multiplied by 1 is 1, 1 multiplied by 1 is 1, 1 again and 0. This is the basic binary multiplication we do in decimals too. Here, whenever we multiply any digit with 0, result would be 0. Again, we have next one. We will multiply all the digits with 1, we will get the same output. Like 1, 1, 1 and 0. And the last one is 0. We will multiply all the digits by the 0 and we will get the answer as a 0. This is the basic multiplication, and this is the basically here we will call all these answers as a partial product, and for final product we have to add all these partial product and we can have our final product. So let's add. It's 1, 1, 0, 0, carry 1, again carry 1 and 0. So here we are having the output as 0, 1, 0, 0, 1, 1. So, here we are having 4-bit number, means here you can see that product of n-bit number is always 2 n-bit number. So we are having 2 4-bit number, hence product of these 4-bit number always be a 8-bit number. But we are having in our answer 1, 2, 3, 4, 5, 6, 7, 7-bit number. So what we will do, we will just add 1 0 here to make it as a 4 into 4-bit number multiplied by 4-bit number multiplied by 4-bit number. We can have as an output as a 8-bit number. So this was our basic binary multiplication. Let's come to the array multiplier. An array multiplier is a digital combination circuit used for multiplying 2-bit numbers by employing an array. Again, an array multiplier is a digital combination circuit used for multiplying 2 binary numbers by employing an array of half adder and full adders. Okay, so this is a very fast way of multiplying 2 numbers. The array architecture is a popular technique to implement the multiplier due to its compact structure. To form the various product terms, we use AND gates and some adder. Here you can see that principle of array multiplier. What is the main basic principle? Whenever we whenever we multiply 2 digits, we can have output in this kind of form. So the combination of these digits multiplied by this, we can have this partial output as we have seen earlier, and combination of these digits again we will do with the multiplication with b1, and all the digits will be multiplied by b2 and b3. We will write all in this kind of sequence, and we will add all these steps. How we can do with the how we multiply all the digits? We just need a multiplier. How we will do the multiplication? We just need an array multiplier. So here you can see that in the earlier slide I have told you one structure of principle of array multiplier. Here you can see an example. This is basically a multiplicand, this is a multiplier, and we are having some partial products. After adding all this partial product, we can have the final product. But in array multiplier, we use some AND gate and adder. How this task can be performed? Like whenever if we want this digit, let's take an example. So what we will do, we will take a digit from this and multiply by this. So we can have this answer. Let's suppose all these digits are the combination of mj, and these digits are the combination of qj. So whenever we multiply any mj with qj, we can have a partial product. So here you can have this partial product by using a AND gate. But another time for getting a final product, we need for getting the final product, we need some kind of additions. So we have some kind of adder. So we will just add all the digits by the final with partial products, and we can have our final product. So this would be the diagram for a single portion for this digit, or any kind of any one of these digits. So next, this is the complete structure of array multiplier. Earlier I have shown you only one piece. This one piece is basically we can use for any one single digit. For all the final solution, we need a 4 by 4 array multiplier, which is basically this. After calculating all the results from this particular circuit and combining with all the circuits, we can have our final answer. So we can have some advantage or disadvantage for this array multiplier. Basically, for the advantage, we have minimum complexity, easy pipeline, easy to place and route. But as well as we are having some disadvantages, high power consumption and more digital gates resulting in large chip area. Means if let's suppose the number of bits get increased, then we have to use more circuits for getting the output. So our next topic is binary multiplication using add shift method. So basically binary multiplication we have done, but this method using the approach of add and shift, it is basically similar to the normal multiplication process which we do in mathematics from array multiplier flowchart. Okay, so here we are having some variables like m, b, a and c. M is denotes for the multiplicand, b denotes multiplier, a is the accumulator, n is the number of bits in available in b, means multiplier, and c we take as a carry bit. So we will do some kind of calculation while using the flowchart. Let's see. This is the flowchart of binary multiplication using add and shift method. We will solve this question by using this flowchart. What this flowchart is saying that, first of all, we will read the LSB of B. Then we will check the value of LSB is 1. If the value of LSB is 1, then we will just add M to A, means the value of M to the accumulator. If LSB is 0, then we will only shift the CAB, the value of CAB. Okay, in every approach, we will just decrease the value in every loop. We will just decrease the value of n. What is n? N is basically the number of bits in B. Okay, so the number of bits in B is the value of n. So in every loop, the value of n will be decreased, and then we check the n is equal to 0 or not. If it is 0, so we will stop the complete execution process, or we will just move to the loop. Okay, let's solve the example, then you can more understand this flowchart. First of all, we can see that here we are having some value of B. So what is the value of B? 110. Okay, so in 110, so in 110 we are having the LSB is 0. So the first of all we are reading the LSB of B. LSB of B is 0, means LSB of B is 0. Then it will move to the N. Initially, the value of C would be 0 and the value of accumulator would be 0, 0, 0, 0. Why 40? Because we are having the multiplicand and the multiplier in the 4 digits. And the value of B we will write here. The LSB is 0. Okay, so we will go to the right shift CAB. What is right shift CAB? Means the value of CAB we will only move in 1 bit. Like this 0 will come here, this here, and this 0 will go here. Oh, यहाँ पे थोड़ा सा रुक जाना. And this 0 will go here, this one will go here, this will go here, and this bit will be discarded. So again what we will do? We will do n is equal to n minus 1. Initially n's value was 4 because we are having the 4-bit B. Now n's value will be decreased, so n is equal to 3. Again we will follow the same steps. Now the LSB of B is 1. So what we will do, we will add M to A, means the value of M would be added to A. Let's do it here. If I add 1101 with accumulator's value, so what answer we can have? 1101. Again we will write here the updated value of accumulator 1101, and initially the value of carry is 0. Again the value of B is the same. Then we will apply the right shift CAB. We will shift each digit by one place. This 0 will be here. 1, 0. This will go here. 0, 1, 1. And this will be discard. So here now we will move to the next step. N is equal to n minus 1. So n's value would be 2. Now come to the again. Note LSB of P. LSB of B is equal to 1. So we will again add M to A, means the value of M would be added to A. Currently A is having 0110 and M is having 1101. So the updated value would be 110, again 0 and carry 1. Again we will have the same answer as 1011. We will apply the right shift CAB. So this will these bit will be shift by one place. So 1 0 0 1 1 1 0 1 and carry would be 0 again. Now we will decrease the value of n. Now n is equal to 1. Again we will check the value of LSB is B's LSB is 1. So again we can see that whenever LSB is equal to 1, we have to add M to A. So the current A is having this 1001, 1001 and M's value is 1101. So 110 again carry is 1, 1 again value is 0, carry is 1, means now carry's value is 1 and the updated A is 0 1 1 0. And we will copy the value of B here. So we will apply the right shift operation. So we when will we go here? 0 1 1 0 1 1 0 and carry would be 0. So now we are having the value of n is equal to 0. Whenever we have seen that n is equal to 0, we have to stop. So the final answer would be this. So here we have seen that whenever we are doing any kind of multiplication between two numbers, 4-bit number, we are having the output as a 2n bit number. Means if n the size of bit is 4, then we are having the output as 8-bit solution. And we have to just keep the we have to see the value of B here and the M's value will be added to accumulator. So in this particular complete calculation, if you want to verify your answer, you can convert them to digital and you can get the final output. Like if you can say that if let's suppose if we want to verify this answer, we can also use our basic binary multiplication approach and can match the answer is right or not. For verifying the output with the inputs, we can also use our basic approach. Earlier I have told you that let's do this same calculation with our basic method. So we were having the value of M was 1101 and 111. So 0 multiplied by all the digits, we can have the answer as 0. 1 multiplied with all the digits, we can have 1 multiplied by all the digits, again 1 multiplied by all the digits. We will add all the number like 0, 0, 1, 1, 1, 0 with carry 1. Here we will have answer as a 1 and carry is 1. Answer as 1 is carry is 1 and 0 and so on. So here you can see that output is same. Let's verify. 1 0 1 1 0 1 1 0 1 0 1 1 0 1 1 0. So in our basic operation, whenever we perform a basic binary multiplication, we can have the answer as same with the add shift method. So just for your revision, quick revision, I just want to say some few steps. First of all, you need to understand, let's suppose this is our M and this is the B. You have to keep some quick points in your mind. Like, first of all, you have to check the LSB of B. Okay, this one. If the value of LSB of B is 0, then you have to only do the step right shift of C A B. इसको मैं फिर से कर रही हूँ. So whenever you will have the LSB of B is 0, then you have to simply write shift C A B. Means the value of C, the value of accumulator currently, and the value of B. You have to shift the digit only one place, all the digits. But if the value of LSB is 1, so you have to add the value of M, means this one, with the value of A, accumulator. Means currently whatever accumulator is having the value, you have to add all these numbers with each other. Then whatever you get answer, you will update the value of accumulator. Then you will again follow the step 2. This is step 1, step 2. Then you have to follow step 2. And here, if the value of B is 0 or 1, if you have completed these steps, then simply you need to update, means decrease the value of N minus 1. Okay, in each step. Then we will check the condition of N. Then if N is equal to 0, then we will stop. Otherwise, we will follow all these steps again and again. Okay. So first of all, you have to check the LSB of B. Then write if the LSB of B. Here you can see that if LSB of B is 0, then write shift CAB. Otherwise, LSB is 1, then M plus A, then follow the step 2, means write shift CAB. If you have completed these steps, then you have to simply update N minus 1. Means if LSB is 0 and you have shifted right shift CAB, then you have to go to this step. And then finally, you have to just update the value of N and check N's value is 0 or not. If the N's value is 0, then stop. Else, if N's value is something else, then you have to repeat all these steps. Repeat from first step. Okay, so you can see that the complete flowchart is having some steps. You can see over here, and this is our complete flowchart or end example with these steps in add shift method. Thank you.